In this example, or in this video, we're going to look at the worksheet overview number 1 in terms of what we learned about columns and rows. So first off, we start with everything in the known universe is either, and we know that everything in the known universe is either matter or energy. We learned that previously. All matter is made up of atoms. And there are currently 118 different types of atoms, about 28 man-made, and then about 90 originally made by God when He created the universe. So previously we talked about other science classes where you've learned about energy, we've learned about light, we learned about heat, we learned about sound, we've learned about, in earth science you can think back to all the minerals and did a little bit of chemistry in earth science, as well as the stars and the earth and the mantle and all that. So you can just pick any topics that you've previously studied in chemistry. And then we're going to jump down here. You'll also have the opportunity to learn that a lot of chemistry is simply determined by the number of, and this is very important, by the number of electrons, simply determined by the number of electrons in an atom. So a lot of what we're going to be doing in this class is simply determined by the number of electrons in an atom and the energy level in which they are located. If we can come up with this information, the electrons in their energy level, that is going to give us a tremendous amount of information about what the atom does and why it does it. So this is why we're spending so much time on the structure of the atom. You'll see how the periodic table is organized by, and on our last video we talked about how it's organized by rows and columns, and we're going to find out that those rows and columns are going to provide an immense amount of information about the location and number of electrons, and that's going to help us determine an immense amount of information about each atom. So let's go ahead and get started. This is a paragraph that we're going to use as a model for many other paragraphs as we write about atoms. So we're going to find sodium on the periodic table. Sodium does not match its name with its symbol. So sodium's name and symbol don't match. It's number 11 on the periodic table. So it maybe take a little bit of time to find sodium. And as soon as I highlight in sodium, and you don't need to highlight because you have your whiteboard periodic table, but I notice there's two things that I notice about sodium. It's in column 1A and it's in row 3. So the first thing, it's number 11 and it's in column 1A and row 3. It's atomic number 11 and it's in column 1A and row 3. Because it's in column 1A and row 3 and number 11, that's going to give us a lot of information about this atom. Sodium is number 11. We know that sodium's atomic number 11 because every single atom of sodium, we're looking at every single atom of sodium. So we're taking one of those atoms, we're zooming in and looking at it. Because every atom of sodium has 11, the atomic number tells us something, and it tells us the number of in the nucleus, the number of protons in the nucleus. Because they said 11 something in the nucleus, we know it has to be protons because that's the particles that are in the nucleus. And 11 electrons. I love this word used here. Arranged. These electrons aren't just randomly flying around. They are specifically arranged outside of the nucleus, the outer part of the atom, and that outer part of the atom is called the electron cloud. How are those electrons arranged? They're arranged in energy levels. How do we know how they're arranged? That's what the next sentence is going to tell us. Sodium is also located in column. Remember, columns going up and down, and it's in column 1A. We are ignoring, right now, we're ignoring all of the B columns here in the middle and the bottom rows. We're just looking at the A columns right now. Column 1A, it's in 1A, and row 3. So it's in column 1A and row 3. Why? Why is it sitting in column 1A and row 3? What does the column give us and what does the row give us? Column 1A, because every atom of sodium has blank of those 11 electrons. Remember, the total number of electrons is 11. 1A, because every atom of sodium has 1. Remember, the column number tells us, the A column number tells us the number of electrons on the outside. 1 of those 11 electrons on the outside in energy level number. The row told us how many energy level numbers, so it's energy level number 3. Now, what I would like you to do is add a drawing of what we just wrote about onto your notes where you previously took notes in your notebook where we spoke on groups and columns. So we're going to take this sodium paragraph and we're going to make a drawing of it. The first thing we're going to draw are the 11 protons in the nucleus. There's 2 ways that I can do this. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 protons all packed tightly together in the nucleus. Then I got to draw the outer part of the atom. The outer part of the atom has 3 energy levels because it's in row number 3. So I'm going to draw a sphere. It's just going to look like a circle, but it's really a sphere, like a ping pong ball. Then on the outside of that, I'm going to draw a tennis ball. And then on the outside of that, I'm going to draw a softball. These are all spherical shapes where the electrons, this whole area is the electron cloud, 3-dimensional shapes. And now I've got to draw the electrons in. Now the first thing that I'm going to do is draw the outermost electrons. We're going to find out that those are the most important electrons. The reason they're the most important is as an atom flies around, it's going to bump into other atoms, and it's the outer part of the atom that's going to be contacting each other, or connecting with each other, or sticking together with each other, or bonding with each other. It's the outer part of the atom that's the most important. Sodium is also located in column 1A and row 3. Row 3, so 3 energy levels. 1A, because it has 1 of those 11 electrons all alone in energy level number 3. So on the very outside, I'm going to draw 1 electron. 1 electron on the very outside because it's in column 1A. Now, someone's going to say, well, wait a minute, Mr. Hodges. We've got 11 electrons and you've only drawn 1. How do I know where the other 10 electrons go? Well, let's look at the periodic table. We're going to walk through the periodic table like we're playing Monopoly until we get to space 11. As we walk through, we're going to count. We're trying to get to sodium number 11. We start with row 1 and we count over 1, 2 spaces. It's like we're taking our little chemistry piece and we're moving it through. Row 1, we count 1, 2 spaces. That means, remember, row 1 is energy level 1. Because we count 2 spaces, we put 2 electrons into row number 1. We're trying to get to an 11. We rolled the dice. We got 11. We're trying to walk our way through to get to 11. Now we go to row 2. And we count 1, 2, 3, 4, 5, 6, 7, 8. We counted 8 spaces across. Row 2. Row 2 is energy level 2, and we counted 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And then in row 3, we only count 1 space because it's in column 1A, and I've already put that electron in. Let's count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's why sodium's number 11. From row number 1, energy level number 1, 2 electrons are in energy level number 1. Row number 2, 8 electrons are in energy level number 2. And then row number 3, it's the first one, 1 electron in energy level number 3. This, we need to put a title on it, is the atom of sodium. 11 protons that are in the nucleus. So we can draw an arrow to the nucleus with 11 protons. 11 with a P and a plus, indicating 11 protons. These here are the energy levels. There are 3 energy levels because sodium is in energy level number 3. Energy level 1, energy level 2, energy level 3. You can think of energy level number 1 like a ping pong ball, energy level number 2 like a tennis ball, energy level number 3 like a softball. These electrons are flying around the surface of that energy level. And then we have the electrons 2 in energy level number 1 because of row number 1. Row number 1 means energy level number 1. 8 in energy level number 2, row number 2. And then finally, 1 in energy level number 3. 11 total electrons. And what did we say about those 11 total electrons? 11 electrons. Sodium is also located, here it is. Protons in the nucleus and 11 electrons arranged. Why did we use the word arranged outside the nucleus in the electron cloud? Because they are arranged. 2 of them are arranged in energy level number 1, 8 of them are arranged in energy level number 2, and 1 arranged in energy level number 3. How are they arranged? Based off of what row numbers they are in. 2 going across row 1, 8 going across row 2, and 1 finally getting to number 11, sodium. I hope this helps in understanding the structure of the atom. The inside with the nucleus, the outside with the electron cloud, and how those electrons are arranged in the energy levels of the electron cloud.